All right, so I think we got through all of that and that. Okay, we didn't talk about this, but let's go on and talk about those rules that Danny mentioned right here. Okay, so these rules are regarding natural log, but they work pretty much the same way. Okay, remember with natural log, the base is e. So we say natural log of 1 is equal to 0 because this asks, what do we raise e to in order to get 1? Well, e to the what? 0 is equal to 1. Okay. All right, then natural log of e is 1. Okay, why? This asks, what do we raise e to get e? E to the 1 is e. Okay. All right, so natural log of e to the y asks, what do we raise e to in order to get e to the y? Not e to the y, but just y, right? So we raise e to y to get e to the y. Okay, and this is the example of why natural log and e cancel each other out, no matter what that exponent is. Does that make sense? Okay. All right, and then here we have, this is the one that I think we had trouble with, but this is e raised to natural log of x. Well, this piece says, what do I raise e to in order to get x, right? Well, x is some random number. I don't know, but I'm going to take whatever it is and I'm raising e to that thing. And so what should we get out of that? No, just x, right? This thing, the piece that I have highlighted here says, if I raise e to this, I'm going to get x. So what are we doing? We're raising e to this thing. So what should we get out of it? X. Okay. To write it out doesn't make sense to me, but that's what we have. Does that make sense? So again, they cancel each other out. Still doesn't make sense? Well, well, yeah, we do know e and natural log cancel each other out. Yes. Yes, that's the shortcut. The question is, why do they cancel each other out? Really, but you could think of it that way. Okay. Say that again. How does it change the product? Well, this isn't a product. We're talking about natural log of x. So when we talk about natural log of x, what we know, what that's saying is, what do I raise e to in order to get x? Okay. Let's say we said natural log of x is equal to y. Okay. Then what that says is, if I raise e to y, then I'm going to get x, right? That's what natural log of x equals y means. So if I do e to the natural log of x, okay, and then we just said, well, natural log of x is equal to y, and then we said e to the y gives us x, okay? So this thing says, what do I raise e to in order to get x? Okay, call it whatever you want. But then what I do is I take e and I raise it to that thing. And we just said when I do that, it should give us what? X. Okay. Makes sense? Doesn't make sense? Yes? No? Okay. If we said, as far as a real example, if we said e to the natural log of 2, okay? So, um, yeah, they cancel each other out. We just get 2. That's the end result of it. Yeah, that's the end result. Yeah. Yes.
Um, I don't get the natural log e raised to the y equals y.
Where's that?
Rule number three.
Rule number 3. Okay. Natural log of e raised to the y. Okay. Well, again, with with natural log, the base that we're talking about is e, right? Let me clear all this off. So if we're looking at rule number 3, right? That's what you said, right?
Yes.
So natural log of e to the y. So we could write this in an exponential form. We're asking, what do we raise e to? Let's say the answer is x. So what do we raise e to in order to get e to the y? And the answer is what? Y. Okay. No, they cancel out because of that. So the cancel out is a result of that. Okay. All right. So every time, what do I raise? So if we look back here, what do I raise e to in order to get e to the y? It's just y. Mm-hmm.
So the
Because the base for natural log is e.
okay. Oh. 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 I think I
Okay.
get it.
All righty.
But if it equals, in this case that we have written on the board, if it equals x, what does that x mean?
Well, I mean, I just put x. I mean, we're doing it in general. Whatever it comes out to be, I'm calling it x. So the way that I can go from this is what we call log form, and this is more of an exponential form. So the way that I can go from here to here is say e to the x, because the answer to this is x. What do I raise e to in order to get e to the y? X. So if I raise e to x, I should get e to the y.
So y is equal to x.
Yes.
Okay.
hmm Okay, questions about that? All right, very good. I think we've already done the examples like this, but let's see what's next. Oh, actually, I think we did them in the homework. All right, but let's see what we got. Okay, let's see. We've already looked at some in the homework that were like this. Here's where we're going. Let's see if this will work for us. Suppose we have this equation. We got natural log of 3x is equal to 2. Okay? So we could rewrite that in exponential form by saying what? It's not on the handout.
E of 2
hmm But write it down somewhere. Okay? What is it, Danny?
e of 2 equals 3x.
E squared equals 3x, right? This, when we talk about natural log, we know that the base is e, right? And so this says, what do I raise e to in order to get 3x? And it's e squared is equal to 3x. Okay, does that kind of make sense?
Okay.
For natural log, yes. Okay, for natural log, the base is e every time. Okay,
When you say write it in exponential form, what does that mean?
this is exponential form. This equation has the same information that this one does.
Okay.
Okay, so again, natural log says, what do I raise e to in order to get 3x? And the answer is 2. So e raised to 2 should give me 3x.
So exponential form is just everything but without the log or natural log.
Yes. Okay, we write it using exponents.
So the subscript of natural log is always going to be e.
Yes. Yes. Okay, the base for natural log is e. Okay, and if I wanted to solve this equation, I could just divide both sides by 3. X equals e squared divided by 3. And if we needed to, we could punch that into our calculator and get a number. Okay, so that's how, we're using the exponential form in e. Okay, questions about that? All right, let's see if we can go back to our notes. Yes. Okay. All right, we talked a little bit about the functions being inverses of one another. Okay, and maybe that might, since we've explored logs and exponents, may make a little more sense now. Let's see if we can demonstrate that here. We've got f of x equals 2 to the x, right? So if I wanted to evaluate that for x equals -2, what is that going to look like? Okay, 2 to the -2. Okay, and 2 to the -2 is going to be what? 1/4, right? Okay, all right, very good. It'd be 1 over 2 squared, or 1/4. Okay, very good. All right, what happens if we look at then in this function 1/4? Okay, and we plug it in here. Okay, so we're talking about log base 2 of 1/4. What do I raise 2 to in order to get 1/4? And the answer is -2. Okay, so you see how it just kind of they undo each other. We started out by putting -2 in for x in this function, 2 to the x. We got out 1/4. When I put 1/4 into this function, I get back out -2. If that happens for every value that we put in, then those functions are inverses of one another. Okay, all right, so let's go on down. If I put in -1, 2 to the -1 is what? 1/2. Okay, let's go to 2 to the 0 is what? 1. 2 to the 1, 2. And 2 to the 2, 4. Okay, let's see what happens if we undo this. If I put into this function, I'm going to put a line here to divide the 2 because these are different functions. So, all right, if we put 1/2 in here, we're asking log base 2 of 1/2 is what? -1. Right? What do I raise 2 to in order to get 1/2? The answer is -1. So we see that they undo one another. Okay? All right. For let's see, we got out 1. So what do I raise 2 to in order to get 1? The answer is 0. Okay, very good. And if we have 2, what do I raise 2 to in order to get 2? 1. All right, and then for 4, what do I raise 2 to in order to get 4? It's 2. Okay, so that's why we say they are inverses. And the x and y values for inverse functions are switched. If we were to write the xy pairs for this, for f of x equals 2x, or 2 to the x, then the pairs look like -2, 1/4, right? -1, 1/2. 0, 1. Okay, 1, 2, and then 2, 4. Okay, but if I write the pairs for f inverse of x, okay, we get what? 1/4, -2. What else? 1/2, -1. Okay, well, 1, 0, 2, 1, 4, 2. Okay, so you can see that the x and y values are just swapped, right, when we talk about inverse functions. All right, okay, questions about that? All right, very good. Okay, all right, well, let's look at some calculator stuff. We're probably finally glad to look at that. So, hopefully, you have your calculator. And you probably already figured out how to use the calculator. But in case you have not, okay. On the calculator, okay, we're looking at example 3. It says evaluate these common logarithms. When we say common log, that means base 10, right? So you can see that common logarithms um, with the calculator. Okay, so here's the log key right next to the 7. I don't know, about 3 is fine. hmm Okay, so if we hit log, and the example is 34.5, so log 34.5, and that's it. Okay, now how could we interpret that? Or if we wanted to check it, what do you think we would do with this to check it? Very good. Okay, take 10 and raise it to this thing. So I'm just going to do second answer. Because if we round off, it's going to be off. But if I do 10 raised to this, I should get out 34.5. Second, and the negative key. We'll pop in the previous answer. Okay. All right. So what's log of 0.43? Okay. Log of 0.43 is negative 0.36653. Okay. Or if we were rounding, negative 0.367. Okay. All right. Okay. Why did you get an error for the next one? Okay. All right. And um, give me more detail about that. Why can't it be a negative?
Oh, you can't raise 10 to anything to get a negative
Right. Okay. The base is 10. And no matter what I raise it to, it's never going to be negative. Right. So we get an error when we try to do log of -3. No real solution, not defined, undefined. Why can't you do 1 over 3? That's not equivalent to anything in this. So when we talk about log of -3, let's look at it. Okay, so this says, let's say it's x. What do I raise 10 to in order to get -3? Well, 10 is a positive number. And no matter what I raise it to, I'm always going to get a positive number. Okay, so this has no solution. Okay, very good. Alrighty. Um, okay, did we do the next part with solving simple log equations? We already did that? Okay, good. All right. And then, okay, so here's some more evaluating with the calculator. This time we're doing natural logs. Okay, so the natural log key is next to the 4. All right. And if I want to do natural log of 23.5, I just put that in, natural log 23.5. And so I got 3.157. How could I check this answer? Raise what to that answer? E. Okay, so if I come down here and say second natural log, that gives me E with a place for the exponent. And second answer, we get 23.5. All right. Natural log of 0.48 is what? Okay, very good. And then natural log of -5 is what? Okay, very good. No real solution. All right, we're getting error. All right, undefined. All right, questions about that? Okay. You can say undefined, no solution. Yep, either one of those, undefined or no solution would be appropriate. All right, very good. Okay, so let's just talk about this briefly, and then we're going to look at some more practice. I'm looking at, I know we've jumped around a bit, but that's okay. Let's just not get deep into it, but let's just talk about properties of the graph of natural log. Okay, what did we just see with those last two examples where we got the errors? It's never negative, right? Natural log is never negative. So if someone were to ask me about the domain of natural log, we just said it's never negative. Very good. The domain is from 0 to positive infinity. We saw that natural log and log is they're never negative, the base functions. Okay? Because if I've got, I think when we defined it back at the very beginning, we said that the base had to be positive. So there's no way that I can take a positive number, raise it to a power, and make it negative. That doesn't happen. Okay? So we know it goes from 0 to infinity. But other than that, as far as the range, okay, it's all real numbers, minus infinity to infinity, all real numbers. Okay? Let's see. All right, so let's start taking a look at the graph. Okay, the point that's going to be on the graph, and we're doing it for right now, natural log of x. Okay, we know that f of 1 or natural log of 1 is what? 0. Okay, natural log of 1 is 0. So the point 1, 0 is going to be on the graph. Okay, and then the graph looks something like this. Okay. And if you go back and look at the very first thing we did, I think in this section, we kind of drew the inverse functions. All right. And so hopefully now that starts to make a little more sense why the log function is going to have this basic shape. Okay. All right. Okay, so that's our basic graph. Some other things about the graph that we want to note. It is continuous. Okay, there are no gaps or jumps. Okay, it is increasing. Okay, I think we can see that for our base function. Okay, now if we put a negative out front, then that's going to change some things. But for the base function, it's increasing. Okay, we don't have any extrema, we don't have any symmetry. Um, we do have an asymptote. Okay, our y-axis is an asymptote. Okay, it's never going to cross the y-axis. Okay, so what do we call the y-axis? What's the equation for it?
X equals 0.
Very good. All right, asymptote at x equals 0. Okay, it's not going to cross that y-axis.
With like the natural log base, it's always growth and it has like a growth factor.
Um,
Or is that thing different?
that would be with any log base. It's going to have this basic shape. Okay, we're doing it for natural log, but if we were doing it for log base 10, it would still have the same basic shape. Okay, very good. All right. Um, and let me just write this in case we see it. We could say that the limit as x approaches infinity of natural log of x is infinity. It's going to continue to grow. It's not growing as rapidly as an exponential function does, but it does continue to grow. Okay, so eventually it'll get up to a million. It'll get up to a billion. Okay, it keeps growing. It's unbounded. All right. Questions about that? All right, so here's our basic graph, our basic shape. All right, when we think about the graph of a log function, then this is the basic shape we need to think about. And we've seen, in several different types of functions, what it looks like to shift functions, left, right, up, down. Okay, so we know the basic function. Here we have the natural log of x plus 2, where that 2 is added on to the x, right? So what is that going to do to our function? It's going to shift it left 2 units.
But how can it if it can't go negative?
Well, the base function can't go negative,
Oh.
but this one can have negative values because not every negative value, but when I put those negative values in, they're still going to come out to be positive.
Okay.
So we're going to shift natural log of x left, okay, left 2 units. All right, so it says describe how to transform the graph into the graph of the given function. So there's this, we could do it if we want. If this is my base function, where this point is 1, 0, and remember we got an asymptote right here. Okay, so the base function looks something like this. Then when I shift it left 2 units, 1, 2, okay, I'm going to have a point right here. Okay, I can shift my asymptote left 2 units. So that's going to be 1, 2. Okay, I'm going to have an asymptote right here. Then the function, we'll do it in green. At least we'll try to do it in green. Okay, we'll do it in black. This is g of x. All right. It probably doesn't go up quite that fast, but just we shift it left 2 units. Okay. So g of x equals natural log of x plus 2. Okay. Yes. Okay. The asymptote is shifted too. Okay. Then in B, what's going to happen?
It shifts to the right.
It's gonna reflect.
Okay, let's rewrite it so that we have the x first. We got the natural log of,
negative x plus 3.
okay, negative x plus 3. So it is going to shift right,
Oh, no, shift left.
shift left, thank you. Okay, I've lost control of my board. Okay, everything's going crazy. All right, we're going to shift left. Okay, there we go. 3 units. Okay, and it's going to reflect where?
Across the x-axis.
Is it across the x-axis?
The y.
It's going to be across the y-axis, right? Because the negative is on the x. Okay, so let's do that reflection first. Okay, let me see if I can sketch in my basic graph. Okay, the board is gone. Okay, all right. Let's say this is my basic graph. We got a point at 1, 0, and it's going to look something like that. Okay, if I reflect this across the y-axis, then it's going to look like this. Okay, that's just the reflection because of the negative that's on the x. Okay, but then I could move this thing, we said 3 units to the left. So let's see, if I take my key point, 1, 2, 3, okay, then this would be, put my key point there and use that same basic shape, okay, this would be my graph. Okay, I'm sorry all that's in the same color, but I think the board is tired. Okay, questions about that? All right, so while I pass out these next set of notes, why don't you take a look in your homework at problems 22 and 23, okay, and see what we get.
So we're not doing C and D.
Oh, I didn't even see C and D. Well, yeah, okay, try C and D, the next two on the notes instead of what's in your homework.
Yeah, is the graph gonna look different C to Y?
Can you take one of those and pass it back?
Thank you.
Hmm.
Yeah, wait. Does the graph still have the basic format if it's log instead of natural log?
Yes, it has that basic shape.
Thank you.
Hmm. What's that?
Oh, this is the problem.
Yeah, the notes. Okay, all right, let's look at these and then I think we got another example. Ah, okay, let me just get a blank page. I think it's truly done. G of x, they tell us where to start, and we need to solve this problem. Okay, it's log base 3 of 81. So how do we solve that problem?
You raise what? Can you raise 3 to get 81?
Okay, I might write, what do I raise 3 to, which they tell me the answer is x, in order to get 81. Okay, and what's the answer to that?
4.
4. X equals 4. Okay, so we're going to follow the path that goes along to 4. Okay, and that takes us to this next problem. Okay, which asks us what?
What is x?
what is x?
Okay, what is x and
Eight
how are we going to?
8 raised to the 1/3.
All right, 8 to the 1/3 is equal to x. What's another way to write 8 to the 1/3?
What is the cube root of 8?
Cube root of 8. Very good. Okay, using our exponent rules. And so x is equal to what?
2.
2. All right, so we're going to go to the right. All right, so everybody understand? So it is possible in some of the cases that you could go diagonal, excuse me, into one of the circles, but yeah, okay. So let's take maybe about 5 or 10 minutes, talk with your partner, and see if you can help the log find his way home.
What if you get a circle? Where do you go then?
You go into the circle, and it should lead you to um,
Just go diagonal. One diagonal to it.
yes. Okay, let's go with that.
Okay.
All right, we'll see while I check on that.